Close your eyes and imagine this. You're standing somewhere where temperatures regularly hit minus 30 Celsius, sometimes even minus 60. The wind? It's screaming at you with the force of a Category 3 hurricane. And the snow never ever stops falling. Out here, exposed skin freezes in under 2 minutes. Your breath turns to ice crystals before it even leaves your mouth. This is Antarctica, the most hostile continent on planet Earth. No trees, no animals on land, nothing but ice, wind, and silence. Yet somehow, over 1,000 scientists live and work here year-round. Today, we're going inside 7 research stations that shouldn't exist, but do. And I'm showing you exactly how engineers made the impossible happen. Because down here, survival is a daily battle against nature itself. Why are we even here? Antarctica is basically Earth's freezer, the coldest, driest, windiest place we've got. But across the frozen wasteland, more than 70 research stations from different countries dot the landscape. We're talking full facilities with labs, living quarters, power plants, and even indoor farms growing fresh vegetables. Sounds crazy, right? But here's why it matters. Locked beneath 2 kilometers of ice is information that could help us understand our planet's future. The real mission. What's worth risking lives in these conditions? Simple. Unlocking Earth's climate secrets. Drilling into the past. Here's something that'll blow your mind. When scientists drill into Antarctic ice, they're not just getting frozen water. They're pulling up time capsules from 800,000 years ago. Inside these ice cores are microscopic air bubbles, actual atmosphere from when our ancestors were still learning to use fire. By analyzing the carbon dioxide, methane, and oxygen trapped inside, researchers can track exactly how Earth's climate shifted through the ice ages, warming periods, and everything in between. It's like having a DVD recording of Earth's entire climate history. But studying this requires year-round presence. You can't just fly in, grab some samples, and leave. You need permanent bases that can survive anything Antarctica throws at them. And trust me, that's easier said than done. Let's dive in. South Korea, Jongbogo Station. Why does this building look like it's standing on giant robot legs? South Korea's Jongbogo Station in Terra Nova Bay isn't your typical research facility. Built in 2014, this place was designed to survive winds exceeding 200 kilometers per hour. During construction, workers faced storms so violent they couldn't stand upright. Equipment froze mid-operation. One wrong move could mean frostbite in seconds. The solution? Make the building aerodynamic as a fighter jet. The angled roof panels aren't just for looks. They're engineered to deflect snow and wind instead of accumulating deadly weight. In Antarctica, snow accumulation can crush buildings if you're not careful. This 4,458 square meter complex sits on steel support columns that go deep into the bedrock. Why? Because the ice itself moves. If you build directly on ice, your station will crack and shift within years. Everything was prefabricated in Busan, then shipped 10,000 kilometers south and assembled in just 18 months, despite temperatures dropping to minus 40 Celsius. The layout is genius. 3 wings in a Y shape, one wing dedicated to scientific research, another for living quarters and recreation, and the third houses critical mechanical systems like generators, water treatment, and heating. Each wing is separated by fireproof barriers, because in Antarctica, if fire breaks out, there's nowhere to run. Response time is everything. Inside, they treat every degree of warmth like treasure. Windows have 5 layers of thermal glass. That's not just double pane, that's military-grade insulation. Every seam, every joint is sealed with specialized compounds that won't crack in extreme cold. The combined heat and power system recycles waste heat from generators to warm the entire facility. Nothing gets wasted. They've got a full medical suite equipped for emergencies, because the nearest hospital is thousands of kilometers away. There's a greenhouse producing fresh lettuce and herbs, crucial for mental health during the long polar night when the sun doesn't rise for months. Walking through Jongbogo feels like exploring a high-tech submarine, compact, efficient, totally isolated from the chaos outside. If South Korea went practical, Belgium went revolutionary. Belgium, Princess Elizabeth Station. Meet the world's first zero-emission polar research station. Belgium's Princess Elizabeth Station in Queedmont Land isn't just surviving Antarctica, it's doing it without burning a single drop of fossil fuel. Opened in 2009, this 4,200 square meter facility runs entirely on 9 wind turbines and 408 square meters of solar panels. Think about that. In a place where the sun disappears for 4 months straight and temperatures drop to -50 Celsius, they're powering everything with renewable energy. The building itself is a masterpiece. Constructed from super insulated wooden cassette modules, each panel is 53 centimeters thick. That's over half a meter of insulation. The whole structure sits on a flexible steel frame with 4 main supports, designed to handle ice movement and extreme wind loads without cracking. Here's the cool part. The station tilts into the prevailing wind. Instead of fighting the gusts, the design channels airflow over and around the structure, reducing drag and preventing snow buildup. Inside, they've created 40 sleeping berths, multiple labs, a library, and even a sauna, because mental health matters when you're trapped in 24-hour darkness during winter. The water system recycles gray water from showers and sinks for non-drinking purposes, and they use a biological wastewater treatment system, no chemicals dumped into the pristine environment. Princess Elizabeth proves something important. Sustainability is possible even at the edge of the world. But Germany took a different challenge head-on. Germany, Neumayer III. What if your research station could lift itself as snow piles up? Germany's Neumayer III on the Ekstrom ice shelf does exactly that. Built in 2009, this station sits on 16 hydraulic columns, each one capable of independently raising the structure up to 6 meters as snow accumulates underneath. Why does that matter? Because previous German stations got buried by snow and had to be abandoned. Snow falls, wind blows more snow on top, and within years, you're living in a tunnel under the ice. Neumayer III said, "Not this time." The 4,400 square meter facility contains 15 individual living modules, extensive labs, workshops, and a heated garage where vehicles can be maintained without freezing solid. Everything was precision built in Germany, shipped in container modules, and assembled like a massive Lego set on the ice shelf. The insulation is insane. 9 separate layers, including specialized vapor barriers that prevent moisture from freezing inside the walls. The diesel generators don't just make electricity, they're part of a cogeneration system that captures waste heat to warm the floors, melt snow for water, and keep labs at stable temperatures. Inside, there are sleeping quarters for 40 people in summer, 9 in winter. Winters down here mean total isolation. No flights in or out for 9 months. The station also has an underground garage carved into the ice for storing snow vehicles and equipment. Now imagine building in a place with absolutely nothing. No rocks, no shelter, just flat ice forever. India, Bharati Station. India looked at that challenge and said, let's use shipping containers. Bharati Station, opened in 2012, is one of the most innovative bases ever built. Constructed from 134 interconnected shipping containers. But these aren't ordinary containers. Each one was custom modified in Germany with insulation, wiring, plumbing, and equipment, then sealed and shipped 12,000 kilometers to Antarctica's Larsman Hills. When they arrived, the team had just one Antarctic summer, about 3 months, to connect everything before the ocean froze solid and ships couldn't return. The result? A 2,500 square meter facility that houses 47 researchers in summer, 24 in winter. The modular design is brilliant because if one section needs repair or upgrading, you can swap out individual containers without rebuilding everything. The station has state-of-the-art labs studying glaciology, atmospheric science, and biology. There's a desalination plant that melts ice for fresh water, and a sophisticated waste management system that sorts and compacts all garbage for removal. They even have a small library and recreation room with satellite internet, because staying connected to home is crucial for mental health during the long isolation. Bharati proved that smart design beats massive budgets. But what happens when disaster strikes? Brazil, Comandante Ferraz Station. In 2012, Brazil's original Antarctic station burned to the ground. 2 people died. Decades of research went up in flames. Brazil could have walked away. Instead, they built something better, safer, and more advanced. The new Comandante Faraz station opened in 2020 on King George Island, a 4,916 square meter complex that looks like a sci-fi outpost. The design features 2 elevated wings sitting on steel stilts that lift the entire structure 4 meters above the ground. Why? To prevent snow accumulation and allow wind to pass underneath, reducing structural stress. The upper building houses 67 beds, a communal dining hall, library, gym, and lounge areas. The lower wing contains garages, workshops, and storage. Every section is divided by fireproof compartments with multiple emergency exits. They learned that lesson the hard way. The outer shell is a double-layer insulation system with a vapor barrier that prevents condensation from freezing inside walls, a major problem in older stations. Radiant floor heating pumps hot water through pipes embedded in the floors, creating even, comfortable warmth without noisy fans or hot air blowing dust around. The station can accommodate 64 people in summer and operates year-round with a small winter crew. Comandante Faraz is a monument to resilience, proof that setbacks can lead to breakthroughs. But to see how far Antarctic engineering has evolved, you need to look at the longest-running station, Japan, Showa Station. Japan's Showa Station has been operating since 1957, making it one of Antarctica's oldest continuously inhabited bases. Started with just 4 small huts, it's now grown into a sprawling complex of nearly 70 buildings covering 7,000 square meters on East Angel Island. The original team arrived with no icebreaker support, just a small ship that got stuck in pack ice. They had to haul supplies across shifting ice for weeks. Today, Showa is a self-contained village. There are multiple living quarters, labs, equipment sheds, fuel storage, even a small post office where researchers can send letters home, mail that takes months to arrive. The station operates year-round with around 30 people in winter, up to 100 in summer. What makes Showa unique is its layered approach. Instead of one mega building, it's a network of specialized structures connected by heated tunnels so people never have to go outside in blizzards. They've got solar panels, wind generators, and diesel backup systems. Water comes from melting ice in insulated tanks, and waste is carefully sorted and shipped back to Japan. Showa also serves as a logistics hub for other nations. It's got an ice runway where ski-equipped aircraft can land. While Japan built big, Poland focused on speed and simplicity. Poland, Henryk Arctowski Station. Poland's Henryk Arctowski Station on King George Island takes a no-nonsense approach. Built in 1977 and expanded over decades, this station is designed for rapid deployment and easy maintenance. The modular buildings can be assembled quickly and withstand powerful coastal storms. This area gets hit with rain, snow, and sleet all year long. The station sits on rock instead of ice, which means no shifting foundations. That's a huge advantage. Arctowski houses around 20 people in summer, 10 in winter, and focuses on marine biology and climate research. What's interesting is the station's open design. Buildings are spread out to reduce fire risk and allow easy expansion. They've got backup systems for everything, multiple generators, redundant heating, emergency shelters. The location is surprisingly accessible. King George Island has relatively mild conditions by Antarctic standards, with summer temps occasionally reaching above freezing. That accessibility makes Arctowski a popular research hub for international collaboration. So there you have it, 7 wildly different solutions to the same impossible problem. Germany builds stations that rise with the snow. Belgium runs on 100% renewable energy. India clicks together shipping containers. Brazil rebuilt from tragedy into triumph. Each one proves the same thing. You don't conquer Antarctica, you adapt to it. And the engineers who figured this out, they're not just building structures, they're pushing the boundaries of what's possible. Because if we can make life work in Antarctica, we can make it work anywhere. Which Antarctic station blew your mind the most? Let me know in the comments. I really want to hear your thoughts. If you're into extreme engineering like this, hit that like button and subscribe, because next week's bridge story is going to be wild. Trust me, you don't want to miss it. See you there.